Graphs of functions. Graphs of functions, grade 11. This is mathematics paper 1. I have a few random questions here from past examination papers just to help us be reminded of certain concepts that are important as we prepare for our examinations. Question number 1. The following diagram represents the graphs of functions of the following functions. F of x is equal to minus 2x squared minus 4x plus 16, and g of x is equal to 8 over x plus 5, then plus 6. Now, we want to determine the coordinates of A, B, C, D, and E. The method to apply depends on the position of the coordinates you are calculating. If you look at our graphs, we can see that point A and point B, they are the x-intercepts of the parabola. To determine the x-intercepts of any function, we equate the equation to 0. To determine the x-intercept, we substitute y with 0. That means f of x must equal to 0. Then after that, we solve the resulting equation. So we're going to equate f of x to 0 and solve the equation. That will give us the coordinates of 2 points, point A and point B. So there is my equation. I can see that the negative 2 is a common factor of the entire equation. So that allows me to divide the equation by negative 2, divide there by negative 2, and this will lead me to x squared plus 2x minus 8 is equal to 0. Then you can solve the equation using any method of your choice. You can solve by factorization, or we can solve by quadratic formula, or by completing the square. In this case, this one has been solved by factorization. So from the first bracket, x is equal to negative 4, and from the second bracket, x is equal to positive 2. Those are the two values of x. Now I have to decide which value is for A and which one is for B. So I can see that A is on the negative side. So it makes sense that out of these two numbers, the coordinates of point A is to be minus 4 and 0. Then the coordinates of point B is to be 2, 0. Those are the coordinates of point A and point B. Then I have point C. Point C. C is the y-intercept of the graph of F. To determine the y-intercept, we substitute x with 0. To determine the y-intercept, we substitute x with 0 and solve the resulting equation. So in this case, if we put 0 in place of x, the calculation, actually this one you can write down the answer without having to calculate. I'm just calculating to show what I'm talking about. So here I'm going to have the first one is 0, the first term becomes 0, the second one 0, I'm left with 16. Therefore, I can say that the coordinates of point C are 0 and 16. Please take note, if an instruction says find the coordinates of a particular position, then you must write the x and the y coordinate. Now, I've determined the coordinate of A, the coordinate of B, and the coordinate of C. Now, I'm left with the coordinates of D and E. Where is D? If you look at coordinate D and look at coordinate E, we notice that they are the x and y intercepts of the hyperbola. So using the same method, to determine the x-intercepts of any graph, we substitute y with 0. To determine the y-intercept of any graph, we substitute x with 0. So if we put 0 in place of y, this will be 8 divided by 0 plus 5, which is equal to 5. Then we add 6 and simplify that expression to determine the answer that we need for that question. So in simplified form, the value of y is equal to 7.6. So we can now conclude that therefore the y-intercept of the hyperbola is 0 and 7.6. The y-intercept, that is the point D on our graph. So the coordinates of D are 0 and 7.6. Then we now need the coordinates of point E. Using the same method, E is the x-intercepts of g of x. So to determine the x-intercept, g of x must equal to 0. So that means 8 over x plus 5 is equal, plus 6. This is equal to 0. Now we need to solve this equation. This is basic algebraic calculations. 8 over x plus 5 is equal to negative 6 over 1. Then we cross multiply. This will be minus 6x minus 30 is equal to 1 times 8, which is equal to 8. Then I have got negative 6x is equal to, if I take the 30 to that side, it's going to become plus 30. Then this will give me 38. Now I have got, divide both sides by negative 6 and I divide by negative 6. So this will give me the value of x. I have to simplify 38 divided by 6. So for me here, the value of x is equal to negative 6.3. Then I can make a conclusion that this is the coordinates of point E. So therefore, point E is negative 6.3 and 0. Those are the coordinates of point E. I have calculated all the coordinates of point A, B, C, D, required by this question for 8 marks. So the main concept applicable here is that to determine the x-intercepts of any graph, you substitute y with 0 and solve. To determine the y-intercept, you substitute x with 0 and solve the equation. Number 2. Now, question number 2 says, write down the equation of f of x in the form a factor of x minus p squared plus q. Now, if you have done your revision, you should know by now that that form of equation comes from completing the square. So in other words, that instruction we can say complete the square. They are simply asking you to complete the square. So we need to remember, how do we complete the square? So let's complete the square here. One of the methods we can use goes as follows. The coefficient of x squared must be 1 all the time. In this case, the coefficient of x squared is negative 2. So you use factorization to remove that negative 2. And we're going to factor out the entire equation. Take out minus 2 from the equation as a common factor. In brackets, we're going to remain with the x squared plus 2x minus 8. Then to carry on from there, we divide the coefficient of x by 2. Divide by 2 and square the answer. The squared answer that we get, if you divide the coefficient of x, we are dividing 2 by 2, that gives us 1. Then we square the answer. That answer, we add the answer to the expression and also subtract it. So our expression here, the term in the middle is 2. We divided 2 by 2, and then we get our answer. The answer that we get is squared. This gives us 1. Then we bring that 1 to the expression. You add 1 and subtract. So this part of my expression, I have got plus 1 minus 1. Plus 1 minus 1 is coming from that calculation. So let me say it again. You divide the term in the center or the coefficient of x by 2. Then you square the answer. The squared answer, you add it and subtract it from the expression. If you do that, you are going to notice that the first 3 terms of your expression, they become a square that can be factorized into brackets. So the first 3 terms, x squared plus 2x plus 1, those 3 terms, we can factorize them into x plus 1, factor of x plus 1. Then the last 2 terms, minus 1 minus 8, they give us one value which is negative 9. Then you simplify. So when we simplify, the 2 expressions which are repeated, x plus 1 and x plus 1, we can write that bracket once and then put a square. Then to complete our answer, what we do now is that we multiply this negative 2 by this expression. You basically are going to remove the first brackets. So negative 2 times this bracket here, you put negative 2, then factor of x plus 1 squared. Then you also multiply negative 2 times negative 9, and that will give us positive 18. We have completed the square, and the answer is now complete. So just to remind you, when I remove the brackets at the bottom here, this negative 2 multiplies this bracket. So you just put it outside, then it multiplies the last term, which is minus 9. That's how we got this positive 18. So we have completed the square, and this is our answer for question number 2 for 6 marks. The question wants us to write down the coordinates of the turning point of the graph. Hence, give the coordinates of M, which is the turning point of the graph of F. So now we can now make a conclusion from the expression from this expression after completing the square, the expression inside the brackets, you equate to 0 to get the x value of the turning point. So if you do that, you will see that x will equal to negative 1. Then this 18 is the y coordinate of the turning point. So the coordinates of M are minus 118. That is our question number 1 and question number 2 done. When I'm working with a past examination paper, the answers are not important. I ask myself the question of, okay, what does this question teach me if I do it? Or what does it remind me if I do it? So in this particular case, we have been reminded that if you are calculating the x-intercepts, you put 0 in place of y. If you are calculating the y-intercept, you put 0 in place of x. In question 2, we have just revised how to complete the square and read the coordinates of the turning point after completing the square. That's question 1 and question 2 of this whole question. Question number 3, determine the equations of the vertical and horizontal asymptotes of G. That is the third question. Please take notice. The question says, determine the equations you must express them as equations, please. That is very much important. You must express them as equations. So the first asymptote, we equate the denominator to 0. So x plus 5 is our denominator. We equate that one to 0, and this gives us x is equal to minus 5. That is the equation of the first asymptote. That's the vertical one. So the method is equate the denominator to 0. That gives you the equation of the vertical asymptote. The horizontal asymptote, y is equal to 6. This one is a very direct one. Y is equal to 6. So in general, we can say that given the equation of a hyperbola is f of x is equal to a over x minus p plus q, then the asymptotes from this equation, the first one, we always equate the denominator to 0. So that means x minus p is equal to 0, which gives us x is equal to p. The next asymptote, y is equal to q. These are the two equations of the asymptotes of the hyperbola. So in our case, x is equal to negative 5 and y is equal to 6. Question 4. Write down the range of f. Now, the graph of the parabola, we want to write the range. The range of a graph, if you are given a graph, let's say, I'm just quickly going through the idea here. Let's say this is my function. The coordinates of the turning point are P and Q. Then in this case, the range of this graph, the values of y, they start from the y coordinate of the turning point, which is Q, going upwards. So we say y is greater than or equal to Q. That is the range. Or we can say y is an element of, from Q, you write the smallest to biggest up to positive infinity. This is the range of the function. If your graph has this shape and the turning point, let's say the turning point, the coordinates of the turning point are also P and Q, then in that case, the range of the function, the graph starts from negative infinity and ends at point Q, where Q is the y-intercept of the turning point. So we can say y is less than or equal to Q. Or we can say y is an element of from the bottom, which is negative infinity, up to Q. This is the range of the function. So range basically means from top to bottom. Where does the graph start and where does it end? In our case, the turning point in our graph, those are the coordinates of point M. Remember, we determined the coordinates of point M in question number 2. So we know that the coordinates of point M are -1, -1, and 18. So those are our 2 points. Those are the values of P and Q. Range, we are using the X, the Y, the coordinate of the turning point, which is 18 in our case. So the graph starts from negative infinity, but it ends at 18. So the answer is y is an element of negative infinity up to 18. Then remember brackets, square brackets on the side of 18 because 18 is included. Or we can write it in this form. We say y is less than or equal to 18. This is the range for the graph of f, question number 4. Number 5, Determine the new equation of g if it is translated 3 units to the right and 2 units down. Right, once again, remember, when you are answering an examination question, always place your attention on what you learn from that particular question. Now, if a graph is shifting horizontally, horizontal shift, this is the idea. If a graph is being shifted horizontally, the equation changes from f of x to f of x plus p. This is how a horizontal shift is indicated. Then if a graph is shifted vertically, that means the graph is going up or down. Vertical shifting, our equation changes in the following way. F of x will become f of x plus q, where q is the number of units by which we are shifting the function, the graph. So these are the two shifts: horizontal shifting and vertical shift. Now let's look at question number 5 and see how this affects the equation. So the equation of g of x is given is equal to 8 over x plus 5, then plus 6. This is my equation. I want to shift this function by 3 units to the right hand side, by 3 units to the right. Now, if you are going to shift it to the right, you add or subtract the number of units to x. Horizontal shift, you add or subtract the number of units to x. So if you add, the graph will shift to the left. If you subtract, the graph will shift to the right. Please remember that if you add, the graph will shift to the left. If you subtract, the graph will shift to the right. So in this case, I want to shift the graph by 3 units to the right. That means I'm going to subtract 3 units from x. Then I want to shift the graph by 2 units down. Vertical movement, if you add, the graph goes up. If you subtract, the graph goes down. So 2 units down means minus 2 to the value of q, or to the constant that is there. Now simplifying this expression will give us the new required equation. I'm going to call the new equation h of x. H of x will equal to 8 divided by x plus 5 minus 3. That gives me x plus 2. Then 6 minus 2 gives me 4. So the new equation after doing those two movements is 8 over x plus 2 plus 4. That answers question number 5. Then question number 6. Give the values of x where f of x multiplied by g of x is less than 0. I did a whole explanation on this one using various graphs. You can look for that video. It is there. But let's quickly have a look at the answer to this question. Now, at the x-intercepts, the equation at the x-intercepts, f of x is always equal to 0. At the x-intercepts, f of x is equal to 0. When the graph crosses the x-axis upwards, the graph is positive. F of x is bigger than 0. So every part of the graph which is above the x-axis, there we can say f of x is bigger than 0. It simply means the graph is positive. Then when it crosses the x-axis going downwards, the part below the x-axis is negative for all functions. Now, if we say we want to find the values of x for which f of x multiplied by g of x is less than or equal to 0, we must find a section or sections on the graph where the two graphs, when you compare them, when one graph is positive, the other one must be negative, so that when you multiply a positive and a negative, the answer will be a negative answer. F of x times g of x is less than 0. It means this product is a negative product. To get a negative product, we must multiply different signs. So that means we look at our graph and look for some way on the graph where the signs of the graphs are not the same. So the answer basically is determined by the x-intercepts. Now, if you look at our graphs here, let's have a look at the first x-intercept. That means at point E. If you look at point E from the left, at point E from the left side of point E, we see that the hyperbola is positive, but the parabola is negative because the parabola is going downwards. So if it continues to go that way, then it's definitely a negative value. Then we look at point A. If you compare the graphs at point A, starting from E to point A, between point E and point A, the graph of f is below, which is negative, but the graph of the parabola is going downwards from point A to E. The parabola is on the negative side, but the hyperbola up there, it is one part of it which is on the positive side. And we must be careful with this one because there is an asymptote here as well. If you look at point A to point B, between point A and point B, both graphs are positive. Both graphs are on the positive side. Then if you look at point B going to the left side, which means up to infinity, we can see that the hyperbola is positive, but the parabola is negative. So in short, we must look for a section, or we must look for sections where the graphs are having different signs. When one is positive, the other one is negative, and vice versa. That will be the answer for number 6. So yeah, our graphs have negative signs from the, if you check from the left, like we have explained, the values of x where the graphs are not the same in terms of their signs, from negative infinity up to point E. The coordinates of E have been calculated. That will be the first answer. Then where else are they having different signs? Remember, there is a line of asymptote between E and A, which we calculated here to be x is equal to minus 5. So from that point minus 5, between minus 5 and point A, the graphs are not the same. So we can also say from negative 5 and point A. The coordinates of point A have been calculated. It's minus 4. Between minus 5 and minus 4, the graphs have different signs. And also from point B going to the right hand side, the coordinates of point B have been calculated. That's B is 2, so from 2 to infinity, the graphs have different signs. Once again, when you are answering a past examination question, make sure that you answer this question: what did I learn? What am I learning from this? Or what am I being reminded of? Because the most important thing in mathematics is to learn ideas. Sometimes there can be an error, a typing error. If you are learning ideas and concepts, you'll be able to pick it up that, okay, this one is a typing error because the concept is rooted in your mind. We have answered this whole question. Grade 11, graphs of functions, mathematics, paper 1.